50 degrees. Are you able to do that? Oh, this is not bad. Conceptually, it takes a little bit to realize what we're having to do, but once you do the math, it's pretty easy. Really, look. The heat of fusion, we know that. It's 6.01 kilojoules per mole. And the problem says we have 1 mole of it.
Oh.
So that Q is pretty simple. 6.01 times 1 is 6.01 kilojoules. That's just to melt the ice.
Okay.
After it melts, what's its temperature? 0.
0.
It melts at 0 degrees and it ends at 0. Then we've got to continue adding heat going from 0 up to 50. So what's delta T for that second part? It's 50, right? 50 degrees. We know C and we know the mass of the water. What's the mass of the water? 18, right. Because it's 1 mole.
Oh, yeah, it's 2. Okay.
The specific heat of liquid water is 4.18. And the temperature changes 50 degrees. So multiply those 3 together. What do you get?
50.
Nope.
Get 3,762.
I'm going to take a picture of it. Look at these numbers.
2.
We're allowed 1. That number 50 only has 1 stinking sig
So
fig in it. But that's
4,000.
fine. So yeah, it's 4,000. That doesn't look much like 10 to me.
So 4 kilojoules.
Yes. Look at the units on these two Qs. The phase change Q is going to be in kilojoules. The temperature change Q is going to be in joules, the formula gives you. So if you're going to add those two together, you need to make sure they're in the same unit. So it's probably easier to change the joules into kilojoules. But if you like joules better, just change the kilojoules into joules.
No,
Whichever
thank you.
one's fine. So this is the same as 4 kilojoules. Now I see something I can deal with. 6 kilojoules for Q1 and 4 kilojoules for Q2.
So it's 10. 10. 10.
That's how we get the 10.
It doesn't seem so hard.
So that's how we got those. So you need to be aware that when you have a temperature change and a phase change, you're going to have to find Q for all your changes and then add them together.
What is 8 asking them?
Okay, what's 8?
Because that it says find 2 Qs, but it just
All right.
the water.
Now you have water at 100 degrees. That's when I say it's water, I mean that it's liquid water.
Are we done with the notes?
No, Carlos, we'll keep you for this problem.
Okay.
Yeah, but you're adding heat to get it not just to boil, but to then for the steam to go up to 110.
Wait, Mr.
So the phase change is only at 100 degrees. When you go from liquid water to steam, that's all happening at 100 degrees. So then you're going to have steam at 100. You need to continue adding heat until it's at 110.
Whoops.
Let me show you on this. I'm going to keep going back to this. Right here. You're starting here with liquid water at 100 degrees. And where are you ending? Are you ending here? In number 8? No, you're ending like up here. Because not only do we have to change the physical state, we also have to change the temperature. You see what I'm saying? So this part, what equation do you want to use for that part?
MCAT.
No.
Oh, no. No. No.
Boil.
The boiling. Right,
Yes.
the boiling.
Come on, people.
It's liquid water and you need to go to steam, so you got to go that way. That's boiling. Q boiling. Positive delta H. Or positive Q, I mean. Then, this part, what are we going to use? The temperature's changing here. The phase change has already occurred.
MCAT.
So now we would have to use the MCAT equation. The MC delta T.
And then add 'em.
Then add them together. This one, I'm going to tell you, it should be obvious. That part is going to be the bulk, by far, the more Q. And then that's just going to be a tiny little Q, maybe insignificant compared to the boiling part. All right, so if you turn this off, we're on our own now.
Okay.